Section 10.4 today is solving trig identities, but this time it's just like all of our trig identities that we've been solving, but we're going to be using double angles. So you can see that in this first problem right here, cosine 2x equals 1 minus sine 2x. I'm asking you to solve it between 0 and 2 pi in radians. I want exact radians. So when you look at the problem, you can see that we've got a double angle involved in the problem and a single angle involved in the problem. You can't solve for x unless you have all single angles or all double angles. In this case, since this is not an identity that gives me a double angle, I need to change my double angle into a single angle by choosing one of the trig identities for cosine of 2x. We've been working on them for a couple of days now. The one that you want to choose is the one that we used to say when we're just simplifying that we want to choose the one that gets our 1 to cancel out. That's not going to be true when we're solving. When you're solving, you want to get everything in terms of one trig function if possible. So since we know a trig identity that's all in terms of sine for cosine of 2x, that's the one we want to use so that we can get the entire equation in terms of sine. So I'm going to replace cosine 2x with 1 minus 2 sine squared x. Now we've got a trig equation that's got a sine squared and a sine involved. So I know I'm going to probably have to factor and reduce, so I'm going to move everything to one side. I'm going to move it all over here to the right so that I get my sine squared positive. When I move it to the right, I'm going to get 0 equals 2 sine squared x minus the sine x that's already over here. When I subtract 1 and bring it over here, the 1's will cancel, so the 1's are gone. Now we have to try to factor and reduce this and set it equal to 0. So both of these have a sign in common. I'm going to factor the sign out. And when I do that, you can remember that when you set them each equal to 0, that means I'm going to try to figure out where does sine equal 0 and where does 2 sine x minus 1 equal 0. Well, sine x equals 0, if you remember on our unit circle, that means the y value, where have you gone? Up and down, nothing at all. That's going to be at 0 and at pi. Notice I put 0 and not 2 pi because the domain includes the 0 and not the 2 pi. So 0 and then pi. All right, where does sine equal 1/2? Well, you'll have to remember that pi equals 1/2 at your radical 3's. If you'll remember at radical 3 over 2, 1/2, the y value is 1/2, and that happens at your pi's over 6's. So you want to remember that your pi's over 6's are positive in quadrant, sine is positive in quadrant 1 and 2, so we're going to have it pi over 6 and at 5 pi over 6. Okay, so that's a normal double angle one. We're going to have one more example of a double angle one. But this time I'm going to ask you to solve it between 0 and 360 degrees. So this one we're going to pick up our calculator. This time we've got a double angle for cosine with a cosine involved. So instead of replacing it with 1 minus sine squared x, this time we want to choose the replacement for cosine of 2x to be the one that has the sine involved in it. So this time I'm going to replace it with 2 cosine squared minus 1. So we know that one of the double angle formulas for cosine is 2 cosine squared minus 1. Now I'm going to distribute the 3 through and get 6 cosine squared minus 3. I'm going to subtract the 2 and bring it over and get everything in the right order so that we get cosine squared x plus cosine x minus 5 equals 0. Now we've got a trig function or a trig equation that we can factor. You want to get this factored and set each one equal to 0, which I do here. It's 6 cosine x minus 5 and cosine x plus 1. So you're going to get where's cosine x equal to 5/6 and where's cosine x equal to -1. Punch 5 divided by 6 into your calculator and then hit your inverse cosine button and you'll get 33.6 to come in your calculator. But you've got to remember that cosine is positive in quadrants 1 and 4, so you need to subtract it from 360 to get the fourth quadrant angle and get 326.4 as well. Then just punch -1 in your calculator and hit inverse cosine and you'll get 180. Those are the 3 answers that we'll be looking for in tonight's assignment. Okay, now we're going to get into ones where you can't change them all into a single angle, or at least you don't want to do that. For example, here, you only have sine involved, and it's only in a double angle. So the easiest way to solve this one is as a double angle. So we're going to divide by 2 and bring it to the other side, the 2 that's sitting out front. So when I divide by 2 here, I bring, I've got sine of 2x equals 1/2. So now I want to solve for sine of 2x. And you can remember I've got it written over here that sine equals 1/2 at your pi's over 6's. Okay, so we know it's going to be our pi's over 6's. What we have to realize though is that we're solving for 2x, not x, and our original domain was for x. If we're going to solve for 2x, we need to double this domain because our domain is doubled here. So I'm going to multiply the 2 through on my domain, and that's going to give me a new domain which says I want to solve it where 0 is less than or equal to, as you bring the 2 through, 2x, which is less than 4 pi. When you're solving for a double angle, this time you want to make sure that you don't just go around the unit circle one time. When you're solving for a double angle, you need to go twice around the circle instead of once. So when I solve for the 2x, I know that 2x, the sine of 2x will equal 1/2 at pi over 6 and at 5 pi over 6. That's what happens when I go around the unit circle one time. So we know those two. Now what we need to do is go around the unit circle again and hit those same 2 spots on the unit circle. So I'm going to add 2 pi to each one of those. And since we've got 6 in the denominator, 2 pi is the same thing as 12/6. So if I add 12/6 to 1/6, that's where I get the 13/6. If I add 12/6 to 5/6, I get 17/6. So when we're solving for a double angle, the 2x will equal the first 2 and then go around the unit circle again and get the second 2. All right, so that's what 2x is, but the question's not asking us to solve for 2x. The question's asking us to solve for just x. So if 2x equals pi over 6, 5 pi over 6, 13 pi over 6, and 17 pi over 6, if I want to know what just x is, I'm going to multiply both sides by 1/2. You cannot distribute through that equal sign, so realize I'm multiplying each side separately by 1/2. And that's going to allow me to get just the x value now. So now, when I look at it, the x value, because the 1/2 and the 2 will cancel out, is going to equal 1/2 times each one of these, or pi over 12, 5/12, 13/12, and 17/12. So 2x equals the 6th, 1x is going to equal the 12th. Notice that when you come back around and solve for x, the 4x values that we get do land in the original domain between 0 and 2 pi, because this is less than 2 pi. So they all come back. The double angles are between 0 and 4 pi, but the single angles come back in between 0 and 2 pi. All right, so let's try one more. I want you guys to try one. This is going to be a triple angle, and it's going to be solved in a very, very similar fashion. Only this time, I want you to solve it for a triple angle. So we're going to divide by the 2 that's sitting out front, and we're going to get where does the cosine of 3x equal radical 3 over 2. And we'll remember that that also is going to happen at our pi's over 6's. It's going to be radical 3, but cosine is negative, you've got to remember, in quadrants 2 and 3. So we're going to remember that cosine, or the x values, are negative in quadrant 2 and 3, and that we're going to triple our domain because we're solving for 3x. So when I triple my domain this time, you can see that I'm solving going 3 times around the unit circle by getting 0 is less than 3x, which will be less than 6 pi this time. So I need to go 3 times around the circle and hit these 2 spots, which are pi over 6, 5 pi over 6, and 7 pi over 6, all 3 times when I go around the unit circle. So when you're looking at this, if I want to get a negative value for the x, I'm going to get 5 pi over 6, going to hit those 2 spots every time. And so you'll notice over here that as I go around the unit circle 3 times, I've got my 5 pi over 6 and my 7 pi over 6. Now I need to add 2 pi to each one of those, so I'm going to add 2 pi to 5 6 and get 17 6. Add 2 pi to 7 6 and get 19 6. Then I need to go around the third time and add 2 pi to each one of those. So when I add 12 6 to 17 6, I get 29 6. And when I add 12 6 to 19 6, I get 31 6. So we've solved for 3x. Now I want to multiply everything through by a third to find out what just x is. When I multiply through by a third, I'm going to get them all to be 5 18ths, 7 18ths, 17 18ths, 19 18ths, 29 18ths, and 31 18ths. So x is going to equal 5 pi over 18 and 7 pi over 18, and all of the 18ths are going to come out of there. So tonight you're going to have some practice on solving double angles like we did up on example 1 and 2, in which you're going to replace the double angles with one of our formulas, and other ones where all we have is double or triple angles, and in those cases you want to solve them as double and triple angles. The last thing I want to say about tonight's homework is I want you to go back and remember just a little bit about something we learned in the last chapter or a couple chapters ago, when I give you a problem like, how do you solve sine x equals cosine x? Okay, it comes up on tonight's homework and kids are having a little bit of trouble with that. I want you to remember that you want to divide both sides by cosine x. Do not lose a root just because it cancels on one side. It does not cancel on the other. And I'm asking you, where is tangent x equal to 1? That's going to come up on tonight's homework and you're going to have to use that. So don't forget that strategy. It'll also come up when they do something like, where is the sine of 2x equal to the cosine of 2x? Same type of idea. You're going to divide both sides by cosine of 2x. And that's going to ask you, where is the tangent of 2x equal to 1? And we're back to the same thing that we just got done talking about. You're going to solve it the same way we did this one, only this time we will go around the circle twice and get 4 values, and then come back and divide the 2 out and get back in between 0 and pi. So give it a try tonight. I just wanted to remind you of that one trick because it's going to come up tonight.